What if I told you that ancient engineers, without electricity or computer modeling, built structures faster than we do today with our powerful machines? What if everything you think you know about modern efficiency is wrong? It sounds incredible, but Roman Hemusic roads, built 2 millennia ago, still serve as the foundation for modern European highways. And here's the shocking part. Some of them outperform modern roads even today. Amphitheaters that could hold tens of thousands of spectators were built in a matter of years, not decades. Think about that for a second. The secret lies not in magic, but in an ingenious system, standardization, and organization of labor, perfected to the absolute. The Romans turned construction into a mechanism as well, oiled as their legendary army. And once you understand this system, you'll never look at history the same way again. Watch the video to the end to find out how the Romans managed to build fully fortified military camps for entire legions in just a few hours, and why their concrete, in some cases, surpasses modern equivalents. And trust me, the final secret will surprise you. I will reveal the most closely guarded secret of Roman construction, and it is not some secret material, but one word: standardization. It was this concept taken to the extreme that allowed Rome to build so quickly and so much. Everything from bricks and pipes to road widths and camp sizes was standardized. This meant that materials produced in Gaul could be used in Syria without any problems. Engineers did not have to reinvent the wheel every time. Imagine the time they saved. They worked with a set of proven and approved solutions. This system began with fundamental measurements that every legionnaire and builder knew: the Roman foot, palm, elbow, and of course the famous pacus or double step, which formed the basis for measuring miles. When every worker on site operates with the same precise units, the speed of coordination increases many times over. No confusion, no delays, just pure efficiency. There was no need to waste time coordinating plans, drawn up by different craftsmen using different systems. An architect could send a drawing to the other end of the empire, confident that it would be understood correctly, something that even modern projects sometimes struggle with. Take Roman bricks, for example. Unlike many other cultures, the Romans standardized not only the shape, but also the dimensions of several basic types of bricks. This allowed for their mass, almost Hemusic industrial production in special factories. When legions arrived at a new location, they could immediately access ready-made building blocks. No waiting, no delays, instant construction. This eliminated one of the most labor-intensive stages, the extraction and processing of stone on site. Standardization also affected the tools that each legionnaire carried. The famous dolabra, a hybrid of a pickaxe and an axe, was a universal tool identical for the entire army. Each soldier carried not only weapons, but also construction equipment, turning every army into a moving construction machine. This meant that if necessary, a centurion could instantly turn his combat unit into an effective construction brigade. There was no need to wait for shovels or pickaxes to be delivered. Every soldier already had them. Think about the speed advantage this created. Roman engineers created entire catalogs of standard architectural elements. They did not need to recalculate the arch of a bridge or the vault of a basilica each time. There were proven proportions and methods that guaranteed strength and durability. Zero guesswork. The architect essentially worked as a designer, assembling a project from ready-made, reliable, and interchangeable modules. This greatly reduced the risk of error and accelerated the design process, something that modern modular construction is only now rediscovering. This modularity was evident in everything from the layout of military camps to the construction of aqueducts. Each camp had a standard rectangular shape with the same layout of streets and gates. A soldier arriving at any camp from Britain to Egypt could find his centurion's tent or praetorium with his eyes closed. That level of predictability is powerful. This predictability saved a tremendous amount of time in deployment and construction. Even something as complex as water pipes was standardized. They were made of lead by rolling sheets into pipes and soldering the seams. There were about 15 standard diameters, each with its own name, making engineering calculations faster and easier. This allowed engineers to accurately calculate the capacity of aqueducts in urban networks. Repairing such networks was also simplified, as the damaged section could be easily replaced with a standard section. No custom work needed. Roman law also supported this system by protecting engineering plans and standards. Construction contracts were incredibly detailed, describing every material and every stage of work. This created a uniform legal and technical field throughout the empire. Consistency at every level. A contractor in Spain built a bridge according to the same rules and standards as a contractor in Asia Minor. The speed of Roman construction was a direct result of this standardization. And this is where most modern systems still struggle. When you have standard materials, standard tools, standard plans, and a workforce trained to a uniform standard, you eliminate most of the delays. The process becomes a conveyor belt where each stage is predictable and well-oiled, almost like a modern factory. But 2,000 years ago, it was this systematic approach, rather than any single invention, that was the main Roman miracle. And this is the part most people completely miss. Are you ready to learn the truth about Roman legionaries that overturns the usual image of a soldier? Because what you're about to hear changes everything. For most of us, a legionary is a warrior in armor with a sword and shield. But the truth is far more surprising and far more impressive. But the truth is that he was as much an engineer and builder as he was a fighter. And this one detail explains how Rome dominated the world for centuries. Every soldier was trained not only to fight, but also to dig, build, lay roads, and erect bridges. This versatility was one of Rome's main strengths, and one of its most underestimated secrets. Training for new recruits in the Roman army included not only marching and weaponry. A significant part of the time was devoted to engineering work, something modern armies rarely emphasize to this extent. Soldiers were taught to dig trenches, build ramparts, install palisades, and use surveying instruments. They practiced masonry and carpentry, turning them into multi-skilled machines. As a result, the army was not just a fighting force, but a mobile corps of highly skilled workers, ready to build anywhere, anytime. Each legion had a whole staff of immunes, specialists who were exempt from daily duties in order to perform technical tasks. And these weren't ordinary workers. They were elite experts. Among them were surveyors, carpenters, masons, blacksmiths, and engineer architects. These specialists formed the core around which thousands of ordinary legionnaires could be instantly organized to carry out the most complex projects, like a perfectly coordinated machine. This engineering corps was commanded by the prefect of the camp, one of the highest-ranking officers in the legion, showing just how important construction was to Roman strategy. A legionnaire's equipment spoke for itself. In addition to a sword, dagger, and armor, each soldier carried an impressive set of tools. And this is where things get interesting. It necessarily included a delabra, pickaxe, axe, a shovel, or hoe, as well as two heavy double-edged stakes known as sudis. These stakes were used to erect a palisade on the camp rampart. Thus, the legion always had both labor and tools at its disposal. No waiting, no supply delays, instant action. This system allowed the Roman army to move with incredible speed and safety, faster than most enemies could even react. At the end of each day's march, no matter how tired the soldiers were, the legion would stop and build a fully fortified camp. This was not just a rest stop, but the construction of a real fortress every single night. Thousands of people worked in unison, digging a moat, filling the rampart, and installing a palisade on it from the very piles they carried with them. The entire process of building the camp was automated and took only a few hours, something that still amazes historians today. While one part of the legion stood guard, the other two parts worked. Surveyors quickly marked out the standard rectangle of the camp, and soldiers, divided into squads, each performed their own task. No confusion, no wasted movement. This incredible speed and organization deprived the enemy of any chance of a surprise night attack. Imagine facing an army that turns into a fortress before sunset. The legions were not only builders of temporary camps, but also creators of long-term infrastructure, leaving a permanent mark wherever they went. It was the army that built the famous Roman roads that connected the new provinces to the heart of the empire. Soldiers were the main labor force on these projects. They cleared the land, removed soil, laid a multi-layered road base, and paved the top layer. It was hard work, but it ensured the rapid movement of troops and long-term control over territories. Bridge construction was another task that army engineers mastered. And this is where their speed becomes almost unbelievable. Caesar's famous bridge across the Rhine was built in just 10 days. Yes, 10 days. This demonstrated to the Germanic tribes not so much the military power of Rome as its engineering prowess. a psychological weapon as powerful as any sword. Legionnaires drove piles into the bottom of the fast-flowing river, created sturdy supports, and laid the decking using prepared materials, speed, precision, and intimidation combined. Even large civilian structures, such as aqueducts and amphitheaters, were often built with the direct participation of the legions. In peacetime, when the army was not engaged in active combat, the soldiers needed something to occupy themselves with, and Rome used this time wisely. Construction projects were the ideal solution. They maintained discipline, honed engineering skills, and created valuable infrastructure that strengthened Rome's presence in the region, turning idle time into power. This dual function of the army to fight and to build was a brilliant organizational solution. Rome had at its disposal the largest, most disciplined, and most skilled construction organization in the ancient world, a force unmatched in history. When it was necessary to implement a large-scale project, the emperor did not need to look for contractors. All he had to do was give the order to the legion, and the work would begin immediately. This system turned the army into a mobile construction company capable of changing any landscape. Mountains, rivers, forests, nothing was an obstacle. But what if I told you that their main secret was not in the people, but in the material they invented? And this is where things become even more fascinating. In the next chapter, we will reveal the secret of Roman concrete, which still cannot be surpassed, and what scientists discovered about it will shock you. But what if I told you that their main secret was not in the people, but in the material they invented? What if the real Roman miracle was something we still struggle to fully replicate today? In the next chapter, we will reveal the secret of Roman concrete, which still cannot be surpassed in many ways. What many modern engineers don't talk about. Roman concrete really was better in key aspects. This is not an exaggeration, but a fact confirmed by research. This material, known as opus caementicium, was a true technological revolution that allowed Rome to build faster, higher, stronger, and on a scale that was previously unimaginable. It was not just mortar. It was the first true structural concrete in human history. The main secret of this material lay in its unique binding agent. The Romans discovered that a mixture of lime and a special volcanic ash, which they called pozzolana, created an incredibly strong mortar. This ash, mined mainly in the area around Pozzuoli near Mount Vesuvius, had unique chemical properties that changed everything. When mixed with lime and water, it reacted to form extremely durable mineral compounds. Unlike simple lime mortar, which hardens only in the air, Roman concrete was hydraulic. This meant that it could set and gain strength even underwater, a breakthrough that changed construction forever. Think about what that means. It allowed the Romans to build massive bridge supports directly in riverbeds, erect strong breakwaters, and construct entire artificial harbors. Even today, building in water remains one of the most complex engineering challenges. Modern Portland cement, the basis of our concrete, is essentially an attempt to recreate the properties of this ancient material. But in some environments, especially marine conditions, Roman concrete still performs better. The manufacturing process was simple but incredibly effective. Workers mixed lime, pozzolana, and water to obtain a thick mortar. Then they added a filler called caementa, pieces of broken stone, crushed rock, gravel, or even fragments of old ceramics. Wooden formwork was erected on the construction site, shaping the future wall or arch. The mortar was poured into this mold in layers, while the aggregate was added. The result was not just masonry, but a solid, monolithic structure. After hardening, the entire mass turned into a single artificial stone. This was much faster than the labor-intensive process of carving and placing massive stone blocks. And more importantly, it required far less skilled labor. Instead of relying only on expert stonemasons, much of the work could be done by ordinary workers. This drastically increased construction speed and reduced costs, a powerful advantage for an expanding empire. This concrete allowed Roman architects to completely transform architectural design. They moved beyond simple post and beam construction and began using arches, vaults, and domes on a massive scale. Concrete was perfect for creating curved shapes. It could be poured into almost any form, giving architects unprecedented freedom. The most famous example is the Pantheon in Rome, whose dome still stands as the largest unreinforced concrete dome in the world. What's even more fascinating is that Roman concrete didn't just last. It improved over time. Modern studies have shown that chemical reactions within the material continued for centuries, making it denser and more resistant. Seawater, which usually destroys modern concrete, actually strengthened Roman concrete. It triggered the formation of new crystals that filled cracks and reinforced the structure, almost like a self-healing material. This is why Roman harbors, piers, and coastal structures have survived for over 2,000 years, despite constant exposure to harsh marine conditions. The speed of construction using concrete was astonishing. Instead of cutting, transporting, and precisely placing massive stones, workers could simply pour the material into molds. This made it possible to build enormous structures like the Colosseum in record time. Its massive walls are not just stone, they are a complex system of concrete cores combined with arches and vaults. Without concrete, such a project would have taken decades longer if it could have been completed at all. Another key advantage was adaptability. While the best natural pozzolana came from volcanic regions, the Romans learned to create alternatives. They used crushed bricks and ceramics to replicate similar chemical effects, allowing them to produce hydraulic concrete across different regions of the empire. This meant that their technology was not limited to one location. It could be applied almost anywhere, a crucial factor in Rome's expansion. Roman concrete allowed the empire to build quickly, cheaply, and on an enormous scale. It required fewer skilled workers, used widely available materials, and produced structures that could last for millennia. In many ways, it was the perfect construction material, efficient, flexible, and incredibly durable. Rome didn't just build with stone. It literally poured its empire into existence. And this raises an important question. If an ancient civilization could create a material this advanced, why are we still trying to match it today? What if I showed you a time machine that still works today? It's the Roman road. The famous phrase, "All roads lead to Rome," was not just a metaphor. It was a reality built with precision, discipline, and unmatched engineering. The Romans created the most advanced and extensive road network in the ancient world. And what's even more impressive is the speed at which they built it. These were not temporary paths, but permanent arteries of an empire. Road construction was primarily a military task. Roads allowed legions to move quickly and maintain control and respond instantly to threats. Speed was everything, and the Romans mastered it. It all began with surveyors who mapped out routes with incredible accuracy. Using simple tools, they created roads that ran straight for kilometers, cutting through hills, forests, and even swamps. Where others would go around obstacles, the Romans went straight through them. Once the route was marked, the real work began. Soldiers dug deep trenches to remove unstable soil and create a solid foundation. They understood one critical truth. A strong structure always begins below the surface. Then came the layers. Large stones formed the base, followed by smaller stones and compacted materials, and finally a top layer of tightly fitted paving stones. Each layer had a purpose, and together they created roads that could survive centuries. The surface was slightly curved so rainwater would drain off, preventing damage. Even today, drainage remains one of the biggest challenges in road construction, something the Romans had already solved. But the real secret was not just in the design. It was in the organization. Thousands of soldiers worked in perfect coordination. Each group had a specific task, and everything moved like a machine. Forests were cleared, stones were transported, layers were laid, all at the same time. There was no waiting, no confusion, no wasted effort. This is why Roman roads could be built at a speed that still seems unbelievable. And these roads were more than just military tools. They became the backbone of trade, communication, and cultural exchange. They connected distant lands into one unified system. Every mile was marked, every route planned, every detail controlled. It was not just construction, it was strategy. But even the greatest engineering requires one final element to succeed: logistics. The Romans were masters of logistics. They controlled resources, managed supply chains, and coordinated thousands of workers across vast distances. Materials were transported by rivers and seas whenever possible, reducing cost and increasing speed. Where water transport was not available, oxen and carts carried massive loads across the very roads the Romans had built. It was a complete, self-sustaining system. Around major construction sites, entire industrial zones were created. Workshops, storage areas, and supply depots operated continuously. Every stone, every brick, every piece of timber arrived exactly when it was needed. Projects were divided into smaller tasks, allowing multiple teams to work at the same time. This parallel workflow dramatically increased speed and efficiency. At the center of it all was strict management. Engineers, overseers, and officials ensured that work stayed on schedule and met exact standards. There was accountability at every level. But beyond tools, materials, and systems, there was one final factor: people. Rome understood something that many still struggle with today. The true power of any system lies in how well people are organized. They broke down massive projects into simple, repeatable tasks. One worker dug, another carried, another placed materials. Each person had a role, and together they formed a perfectly coordinated system. It was an ancient version of an assembly line, long before the modern industrial age. Discipline was absolute. Work continued from sunrise to sunset. Every movement had purpose. Every action contributed to the final result. This is how Rome achieved what seemed impossible. Not through advanced machines, but through advanced organization. They turned thousands of individuals into a single, powerful force. And that is the real secret of Roman engineering. It was never just about concrete, roads, or tools. It was about systems discipline and the ability to think on a massive scale. They did not wait for perfect conditions. They followed proven methods. They built with speed, precision, and confidence. And that is why their structures still stand today, not just as ruins, but as reminders. Reminders that true innovation is not always about new technology. Sometimes it is about using simple ideas better than anyone else ever has. The Romans didn't just build structures. They built a system that built everything. And in many ways, we are still trying to catch up.